All right, guys, Grizzly Risley's here. Thanks for tuning in. We are done with exponent properties, and now we're going to move on to their graphs. So to start off, an exponential function, I'm going to give you its form. So you know how lines have the form y equals mx plus b? We'll just do a quick review. Lines are y equals mx plus b. Today we're going to learn the formula for exponential curves. And here it is. It's y equals a times b to the x power. And let's talk about what those things are. So x is obviously the x values. Y is obviously the y values, but we don't really know what a and b are. A ends up being the initial value or the starting value. And then B ends up being something called the rate of either growth or the rate of decay, depending on what type it is. All right, so let's look at our first two graphs here. So for an exponential growth graph, the graph will be increasing. As x gets bigger, y gets bigger. It's increasing. So the y values are increasing if it is an exponential growth. For all of these graphs, the domain is always all reals, but the range is not. So we'll talk about this a little bit later. There's always, the graph is never going to cross 0. Okay, so what happens is the graph kind of levels off at 0 and then starts rising exponentially. Oof, okay, pretend that goes over it. So since the graph never goes below 0, the range is going to be y is greater than 0. And then if it's an exponential growth, the growth rate will be greater than 1. It has to be greater than 1 if it's a growth. Okay, I'm actually going to cross off the word growth here. We don't need that. All right, now if you look at the graph and it is decreasing, okay, so notice that this one starts high and continues to go down, 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 down. That is called an exponential decay. And you know it's a decay if the graph is going down, so it's decreasing. The y values are decreasing over time. Just like the increasing, the domain is all reals. And just like the increasing, the range is still always above 0. Y is greater than 0. But the one thing that's different is the rate. If it's a growth, the rate is bigger than 1. If it's a decay, the rate is between 0 and 1. So we'll say the rate is between 0 and 1. So in other words, less than 1. So growth is bigger than 1. Decay is less than 1. But it's always positive. Okay, so the next part, I'm actually going to switch to the back. Let's turn the page. Let's do some of these first. Look at these and tell me, is it a growth or a decay? And here's how you do it. You look at that rate, the B term, and if it's bigger than 1, it's a growth. If it's smaller than 1, it's a decay. So these are very, very easy. And if you look at our formula, the number that we're looking at, the B, it's the one that's being raised to the power. So you only care about that number. So let's try some. So in number 1, the growth rate, or I'm sorry, the rate is 2. Well, 2 is bigger than 1, so it is a growth. Now look at 2. If you look at the rate, it's 0.5. 0.5 is smaller than 1, so this would be a decay. Okay, so I just wanted to go over a couple of those. All right, lastly, we're going to talk about how to graph some. And today I'm going to show you by hand. In class, I'm going to show you on the graphing calculator. Okay, but you might want to take out your calculator here. All right, so we are going to raise these numbers. It's going to be 1/2 to the negative 2 power. So go ahead and type that in. All right, so we're going to have the fraction of 1/2, and you know, I should have maybe put it in parentheses. Okay, so we want to raise you don't have to, 1/2 caret negative 2. So we're going to raise 1/2 to the negative 2 power, and you guys will get 4. And then let's raise 1/2 to the negative 1 power. So parenthesis, alpha y equals fraction, and you guys can pause this when you want to. 1/2, raised to the negative 1 power, and you get 2. And then this one you probably don't need the calculator for because anything to the 0 power is 1. All right, now let's raise it to the 1 power, but do we need a calculator? 1/2 raised to the 1 power, isn't that just 1/2? And then you might know this one. What's 1/2 raised to the 2nd power? So let's get our fraction. 1/2 raised to the 2nd power, and that is 1/4. And maybe you guys could have done that without a calculator. All right, all we have to do is plot these points. So we make a point at negative 2, 4. We make a point at negative 1, 2. We make a point at 0, 1. We make a point at 1, half way up. And we make a point at 2, a quarter of the way up. And then you connect your dots in a curvy fashion and never let them cross 0. So it levels off at 0. Okay, if you guys remember from the front, domain is always all reals. And range, it looks like the whole graph is above 0. So y is greater than 0. And then the question is it a growth or a decay? Well, the base is smaller than 1 and the graph is going down, so I bet you guys would know that it is a decay. Okay, feel free to stop the video right now if you would like. If you guys want, I'm going to do one more. What happens when there's a negative out front? And basically what it does is it flips it. But I'm just going to do one more in case you guys want to see. But feel free to stop here. Okay, so same thing. We're going to pull out our calculator and we're going to plug in these values. All right, so you guys are going to do negative 2 to the negative 2 power. Now there's no parentheses, so do not put parentheses. So negative 2 raised to the negative 2 power. And for that first one, you get negative 0.25. And then we do negative 2 raised to the negative 1 power. And for that one, you get negative 0.5. And then we do negative 2 raised to the 0 power. And we know that that is negative 1 because of the negative sign. And then we do negative 2 raised to the 1 power, which you guys know is going to stay negative 2. And then we do negative 2 to the 2nd power. Negative sign, 2 to the 2nd power, and that is negative 4. And because the negative sign is outside, that's why all of these are negative. All of these are negative because the negative was outside. All right, let's plot our points. So we got negative 2, negative 0.25. We got negative 1, negative 0.5. We got 0, negative 1. We got 1, negative 2. And we got 2, negative 4. And then you're going to connect the dots, but you're never going to cross 0. Okay, so for all of these exponential graphs, domain is always all reals. But this one has a different range. So what's the range? Well, this graph is entirely below 0. So your range is y is less than 0. And then because of that negative sign, and because the graph is going down, we call this a decay. All right, that's it, guys. We're going to review this more, I think, on Monday. All right, thanks for watching. Bye.